Okay, let's start. Fine. So yesterday I think we saw about the stream classes. Fine. The top level stream classes: input stream, output stream, reader, writer. We also saw the bridge classes. Fine. Output stream writer, the input stream reader. Okay. Fine. Now, so they are used for input and output. So let's start with the most commonly used ones. Okay. And those four top level classes are abstract. Okay? Fine. Now the most commonly used stream classes. Uh, one will be related to, so what we'll discuss today is related to input output from a file. The classes used for input output from a file, and then we'll see if we can discuss other classes. Fine. So we understand four types of streams, right? Byte stream inward, byte stream outward. Fine. Character stream inward, character stream outward. So same way here also, for input output from a file, we have four different stream classes, each under, fine. So uh, one of each type, right? So for example, we have the output stream, right? A subclass of output stream is the file output stream, and file output stream is a subclass of the output stream. Okay, same way we have a file input stream, and like this, same way we have the file input stream as a subclass of the input stream. We also have a file writer as a subclass of writer. We have the file input stream and we have the file reader. Okay, fine. Four primary classes which are used for input output from a file. Fine. These are the stream classes we are discussing. Okay, fine. Because other than this also there are other classes which can also be used for input output from a file. Okay. For example, there is another class which we are not discussing at this moment. Uh, fine, but we also have a class called random access file, and that's something which is also usable as a for input output from a file, IO from a file. And any input output from a file can be done through this. Another point here, I have listed, yes, we have a file output stream, we have a file writer. Fine. A file is basically made up of bytes only. Fine. So it should have been a byte stream primarily. Okay, fine. So these versions, the file writer and file reader, are not direct subclass of the writer or the reader. Okay, the file writer, for example, extends from, so this one extends from output stream writer. Right? Because what is it? File is a byte. The source or the destination here is made up of bytes. And file is made up of bytes and not Unicode characters primarily. Okay, but yes, we want to have a writer where if we write any data, any text data, it should be stored in that file. Fine, file made up of bytes only. Okay, so it's a special case of file writer is a special case of output stream writer where the output stream is always a file output stream. The output stream is always going to be a file output stream. We don't directly give it in the constructor. The constructors of file writer will match the constructor of file output stream. So when you call the constructor of writer, it's basically creating a file output stream object internally. Fine. And so inside a file writer, there's a file output stream. And it uses a file output stream. Same way, file reader is a special case of input stream reader. Right? So file writer extends from output stream writer. extends from output stream writer, uses a file output stream, internally uses a file output stream, and file reader extends from input stream reader but uses a file input stream. Okay. Random access file is not a stream class, it's not a stream, okay? And we will be having a look at it later on. Okay. Fine. So primary things to do with a file are these three classes, okay? File output stream, the file input stream, the random access file. Okay, these are the primary things which work directly on a file. Okay, physical file, these are the ones which will work on them. Okay, another point, another class which we'll have to discuss here is we have one more class related to the stream classes, file related stream classes. Whenever any file is opened for input or output, there is a file descriptor associated with it. Okay, this is from the OS. Fine, any process, fine, in this case it is the JVM process. Whenever any process opens a file for input or output, fine, there would be a file descriptor created. Okay, any process always has three files always opened up. Fine, we have the three standard files, the standard output, the standard input, and the standard error. STD in, STD out, and STD ERR. Fine. Okay. So for them also, so those are the first three file descriptors which will always be there. So we also have in the java.io package, we also have a class called file descriptor. And this file descriptor class has three static variables. Okay, there are three static variables in this class, which are objects of the file descriptor itself. So in this, so file descriptor, there are three static file descriptor objects in this class. Okay, so we got static final file descriptor object. Okay, in. This is nothing but the file descriptor corresponding to the standard input. Okay, and it would be some file descriptor object. So this is in the file descriptor class. Fine. So there's a file descriptor in. There's also a file descriptor out. There's also a file descriptor called ERR. Okay, these are publicly available. So file descriptor objects for in, out, and ERR. It's a declaration. In equal to, it would be assigned some object of file descriptor. Fine. System creates those objects for us initially. Fine. So that, yes, this file descriptor is nothing but the file descriptor for the standard input. Fine. A file descriptor which is for the standard input. We'll try to understand the relation between file descriptor and these things called file output stream, the file input stream, and even the random access file would use a file descriptor because it is the one which is opening a file for any purpose, reading or writing. If any file is opened for reading or writing, fine, there is a file descriptor for it. Okay, and three files are always opened up, right? When you say system.out.println, or in case of C++, if you are looking at even C++, you have C out. What is that C out? Standard output. Okay, you say C in, standard input. C ERR, standard error. Okay, or you have printf, scanf, eprintf. Eprintf is in case of C language. Fine. Those three are nothing but three file descriptors any process will always have. Always, any process always has these three as opened up. Fine? Clear? Okay, so let's proceed and let's look at the file output stream class first. And we'll start by looking at the object of the file inputs, file output stream class. Yeah. So if you look at the file output stream constructor, object of file output stream, if you want to create a file output stream, you need to specify, there are various constructors. One of them says, okay, you can specify a string for a path to a file. Okay. So when you call this constructor, you specify a path, you give, or maybe the file name. Fine, what will happen? When you call this constructor, a physical file gets created. Fine, you are specifying a file name. So that file is now created of 0 bytes. If such a file already existed, okay, if it exists, that would become 0. Okay, fine. So yes, if you don't want it to become 0, you have another option where you can call the constructor file output stream by specifying two parameters. First parameter, of course, is the path, and second parameter is a Boolean value. Whether you would like to open it for append mode, and you can open for append. Okay, so when you say open second parameter true there, the second constructor, right? If you pass second parameter as true, what would happen? If it is existing. If it is not existing, it will create a new one. Fine, if it doesn't exist, create a new one. But if it exists, fine, it will start appending in the file. Fine, normally useful for log files. Maybe there's a continuous log. Each time you start up, you want to append into the same file, right? Sorry. Okay, fine. So these are the two constructors, primary constructors you have. Okay, another variant of the same constructor, same two constructors again exist in another form, where instead of specifying string for the path, we know of the class called file. So you could use the file object. Fine. So you could use the file object, and append mode could be specified. Okay, you could be using the append mode. Fine. So instead of as a string, you could also, if you have a file object of the file class, yes, that represents the path, so that could also be used here. Okay, there's yet another constructor. Okay, there's yet one more constructor here, a file output stream object. Can also be created by specifying an object of file descriptor. And you can pass an object of file descriptor to create a file output stream object. So some existing file descriptor could be used for creating a new file output stream. See, let's look at this, what exactly happens when we call the constructor file output stream. Whenever, fine, just ignore the last one for the time being. We'll come and discuss that also. What is that file descriptor being used for creating a file output stream object? That's also an interesting one. Okay. But just think this, okay. So whenever we create an object of file output stream, what is happening is, yes, we are creating some object of the file output stream, but whenever we create, we are giving a path. So for corresponding to that path on the file system, a new file gets created. Okay, that's what we know, right? And when we write to this file output stream, those bytes go to that file. It is inheriting from output stream. We have those write methods, and in case of file writer, it is inheriting from the writer. So we have all those methods. It's not inheriting from write, it's inheriting from the output stream writer. Anyway, those methods of writer are available. So all those write methods are available. Flush, close, all those methods are available. Right? So this is what the picture is, right? File output stream. Yes, when you create the object, it is linked to a physical file. Physical file is created, and yes, it's linked to it. Fine. You keep on writing, yes, it will be there. Now, one thing you understand here is when we create an object of file output stream, we are opening a file for reading or writing, and therefore, an object of file descriptor is there. We have some object of file descriptor. Actually, it is the file descriptor object which matches your physical file. For this physical file, I have, in which a reading or writing operation is opened up, right? I have a particular file descriptor object. When you create the construct of file output stream, there is a file descriptor which is created, okay, which is part of the file output stream. The file output stream has that object. We have the method in the file output stream to return a file descriptor. Name of the method is getFD. You can get hold of the file descriptor. Fine. What is the file descriptor when I created this file output stream object? And that you can find out. Okay, there's a file descriptor created because you opened a file for output. Okay, and now what one can do is, okay, get this file descriptor. So this is my file descriptor object, and use this to create one more file output stream. You can even do this because we have the constructor file output stream can be created from a file descriptor. So when you do this, what would happen? Physical file is one, but you have multiple file output stream objects working and writing to the same physical file. Clear? Because they share a common file descriptor. Fine. Fine. There is the other constructor where a file descriptor is used for creating a file output stream object. So file output stream created once has a file descriptor. You have a getFD method to get it. And we also have a constructor for file output stream. So another object of file output stream can be created by using the file descriptor which was already for another file output stream. So then physically single file, though we have two separate file output stream objects. Fine, you could have multiple file output stream objects, all of them writing to the same physical file. Fine, so that's what this constructor is. Okay. Fine. And of course, you want to create a file output stream to write to the standard output. You can do it by using file output stream constructor with passing parameter as file descriptor.out, our standard output. Fine. So you could be writing to the file output stream. It's like sharing the same thing as the system.out, writing to the same place as system.out. Okay. Fine. So your file descriptor.out, and that's here, this one. That's a file descriptor object. Could also be used for creating a file output stream. It's a file output stream, writing to the standard output. Clear? getFD method. Fine. Fine. So other methods which we have in the file output stream, of course, because in 1.4 there was new API kind of added for IO. New. Fine. There was new IO, NIO. So we have java.nio package. There is some. So java.nio also has its own different way of doing input output. Fine, it is an additional way of doing input output where it is more using buffers. There's something called buffer. And yesterday I did mention about some class called care buffer. Fine. So there are actually lots of buffers which are being used by java.nio package. And there for input output, buffer is where the things will be stored, right? It's a place for storage of primitive values. Okay, so where reading or writing is required, we have something called channel in java.nio package. We are not discussing java.nio package, but just one link which is available. Fine. So what is done in the file output stream class? Okay, it's not only the file output stream class where this exists. We have this getFD method not only in the file output stream, it is available in file input stream and the random access file class also, because these are the places where we are opening a file for reading or writing. And primary classes for which open a file for reading or writing, they would have a file descriptor. They have this method called getFD. So getFD common to file output stream, the file input stream, and the random access file. Okay, fine. All three also have another method which returns an object of file channel. We have this method called get channel. Again, this method, so these two methods are common to file output stream, the file input stream, and the random access file. Okay, and get FD and get channel, those two methods. Returns a file channel which is part of, this is part of, there is a package which is java.nio.channels. Okay, we have this package which is part of java.nio. So in NIO, there is a way of reading writing. So reading writing happens through channels into buffers. Fine. For example, the file channel or even the channel, right? We have readable, writable byte channel. Fine. So we have byte channel, fine, as one of the channel classes. Okay, and that byte channel has method like read, where the parameter is a byte buffer. So you're asking it to fill into a byte buffer, but what will we use? We use channels there, not the streams. Stream is in java.io, but what we have in java.nio, channels and buffers. Okay, so this is a link between IO and NIO. Fine. So that yes, you can use this file channel. Once you have a file output stream, you can even have a file channel, so that you can start using the java.nio related API, and you can start using it from here. So that's one entry point into the java.nio. Clear on these two things? Get FD, get channel. So yes, other things from file output stream, it's just inheriting methods from the output stream class. So those write methods and flush methods, which we have already seen. And that's what the file output stream is. What about file writer? So if I look at file writer, the file writer extends from and it extends from the output stream writer, and therefore has all those methods of the writer class. As far as constructors are concerned, the file writer constructors Okay, the file writer constructors are same as the constructors for file output stream. So you can create a file writer by using a string for the path, fine, or string and a boolean for append mode, fine, or you could also create by using the file object for the path, or file object and the append mode, or even a file descriptor. Of course, here you don't have those methods like get FD and get channel. Those methods not available here. Methods available are the methods inherited from the output stream writer. That's a set of methods we have. Methods come from output stream writer, no additional methods. But constructors match the file output stream constructor. So when we call any of these constructors, it is internally just creating the object of file output stream. As far as characters encoding is concerned, which character encoder, char set encoder it will use? It will use the char set encoder whichever is your default character set. Right? It uses the default character set. Fine. It converts into bytes. Your characters, your text, whatever you are giving to the file writer is converted to byte by using the default character set. Okay. Fine. The next thing we can look at is the classes for the input side. Fine, that was for output purpose. We have the other two classes as well. Fine, now the very similar things. So we have this class called the file input stream, which inherits from the input stream. Okay. Fine, the constructor here, a file input stream can be created by using a string for the path to a file. Now this must be an existing file. Fine, what you give here should be a existing file. Fine, then it opens that for purpose of reading. The read methods would give you bytes from that file. Okay, fine. You could also create by specifying a file object for the path, or the third option is to have file descriptor. Even here also you can use a file descriptor. The get FD, get channel methods, as I had mentioned, they are available here also. Okay, fine. When we use a file descriptor, what would it mean? You already have some file input stream created from where you got the file descriptor. So say it's like this, right? When I create a file input stream object, fine, there is some file descriptor which is associated with my physical file. Okay, this file input stream, whenever it wants to read, it reads from this file, right? Now someone creates a new file input stream object using the same file descriptor. Okay, if I read few bytes from here initially, okay, it would read, maybe I read one line using this file input stream. Now if I read here, I'm reading for the first time, saying read one line. What would it read? It would be reading the second line. Okay, fine, be aware of this. When you use a file descriptor, common to more than one file input stream. And same thing was happening when we say file output stream also. I write something from here, that goes to the file. I write something from the other file output stream, it's appended to the same file. And multiple ways, but they all have a common destination. Physical file is the same. Same way, there's a common source. The physical file is common. You can have multiple file input stream objects created. Fine, we have those get FD and get channel methods here. Fine, I'm not repeating them here. Clear? Okay, and same way, if I think of file reader, yeah, file reader, constructors, same three constructors as the constructor for file input stream. So you can create a file reader by using a string, or you could create a file reader by using a file object to specify the path, or you could use a file descriptor as well. Okay. Methods in this case, file reader, the file reader inherits from no, it's not completed. File reader inherits from input stream reader. Methods of input stream reader will be available here. And reader methods basically. And methods for reading text. So reading text from a, but here again the character set is fixed. Okay, so if you are interested in just using the default character set, then file reader and file writer are fine. But if you have some other character set, then you may be better off using the input stream reader and output stream writer directly and creating them. And clear on this? And file related classes. Fine, file related stream classes, 4 of them. Okay, now there are a few other interesting stream classes. Okay, let's look at them one by one. So we have another kind of another pair of stream classes. This is known as piped streams. Piped streams. So which are the piped streams? There are 4 piped streams. Which are those 4 piped streams? We have the piped output stream, right? We got the piped writer, we got a piped input stream, and the piped reader. Okay, fine. See, these classes are always used in a pair. These classes, the pipe streams, are always used in a pair. You can't have just one object. Okay, pipe streams, what do? They create a pipe. Fine, pipe has 2 ends. Fine, we need both 2 ends to create a pipe, right? See, you have an object of a piped output stream, let's say. Fine, we have one object of a piped output stream. No, that doesn't work. Fine. What you need is you also need one object of piped input stream, and they need to be connected, and that forms a pipe, and that forms a pipe. The idea here is, what is it? Okay, it's a piped output stream connected to a piped input stream. Anything you write to the piped output stream is taken in the pipe, and whatever is in the pipe is available for reading by anyone reading from the corrected piped input stream. That's a piped output stream on this side, and that's your piped output stream, and that's your piped input stream. They need to be connected, so they're always used in a pair. And more useful with multi-threading. And this is more useful with multi-threading, where we have some thread which is producing data, fine, and writing to a generating data and putting it in the pipe. Asynchronously, another thread could work on the piped input stream to fetch data from it, start reading from it. Of course, how much data will stay here in the pipe? There is some capacity which the pipe will have. Okay, there is going to be some capacity for the pipe, the buffer size for the pipe. Okay, fine, which would normally be decided by the piped input stream. Fine, it's normally decided by the piped input stream. Fine. So there's some producer thread who produces data, puts into the pipe, and there is a consumer thread which can consume that data from the piped input stream. Piped output stream, piped input stream. So it's piped output stream, piped input stream when you have binary data to be transferred, or it's a piped writer and a piped reader. Okay, fine, the way it works. It's only the type of data which would change, yes, but corresponding thing. And this pipe is something which can't be broken. Fine, that you can't think of, okay, oh, I want to change that destination. Fine, I would like to have a different one and let this connection be broken and put into the other one. No, they are created and they remain in a pair. Once a pairing is done, that pairing is permanent. Let's see the constructors. How do we create the objects of these piped streams? Fine, but fine, these two can be paired. This can be paired with this, or this can be paired with this. Fine, always used in a pair. Single, it's not usable. Just creating one object, not usable. So let's see how the constructors are designed here. So fine, if I want a piped, what should I do? XXX. Okay, I'll put XXX. I'm just saying XXX. XXX could be any one of the four. Each one has an opposite, right? Let me call it as YYY. So if you want to create a piped XXX, you can create it by giving an object of piped YYY. What is YYY? The opposite of XXX. Clear? If it's piped input stream, it's a piped output stream. If it's a piped output stream, it's a piped input stream on this side. Or reader and writer. The pairing. Okay. Fine. That's the opposite side. So that's one way of creating object of piped stream. And they all have, any piped XXX has a default constructor as well. You have a default constructor. So you can create an object of one object first and use it in the constructor of the other one. Fine, you can create piped input stream first and then create object of piped output stream by using the piped input stream object. Fine. Clear? And I'm covering all four in this. I'm not writing individually each one. Clear? XXX and YYY are the opposite, the pairing which can be done, right, between X and Y. We know pairing can be done between input stream and output stream, or reader and writer. Okay, so piped is fine. Fine. And then, as far as the piped, okay, another one is what could also be done is someone creates two independent objects of the opposite type, piped XXX and the piped YYY, let's say. Okay, then what is available is we have a method called connect. All of them, all piped streams, all the four streams have the method called connect, where the parameter is of type piped YYY. Find the opposite. So if it is not yet connected, created independent, you might have created using the default constructor for, fine, no argument constructor could have been used for creating objects of both the types, and then connect one with the other, and the connection is created. Once connected, then nothing, now you can't say connect again. Once it is connected, you can't connect again. They are connected either because of the constructor or with the connect method. But once connected, then they can't be reconnected to something else. Okay, fine. For the input side, that's these ones, the piped input stream and the piped reader, they yet have one more constructor. Fine. What should I call them? Piped. Okay. It's for the piped input stream and the piped reader only. Okay. I'm just doing it for input stream. Okay. Fine. But understand it works even for the piped output stream. The constructor is available where we can specify an integer for the pipe buffer size. Okay, I'm putting buffer size here. The size of the pipes buffer. Okay, that can be specified in the construct of the piped input stream or the construct of pipe reader. And you can do it also while giving the parameter of pipe by overloading. So you got your piped output stream and an integer for the buffer size. Methods point of view, yes, connect is the only new method. Other methods are the inherited methods. Methods inherited from the superclass. Fine, the piped streams directly inherit from their base stream class. Okay, so piped input stream inherits from input stream, piped output stream inherits from output stream. Clear? Okay, so we saw about the streams related to the file and pipe streams. Fine, we'll continue next time. Okay.